Okay. Hello, everyone. Let's start our class today. Okay, if you can hear me, you can send some bullet screen message so that I can know that you can hear me well. Okay. I mean, you send bullet message from Ring class and not on Zoom. Okay. Because during this class, you may be asked to answer some questions. So I have to make sure that you can know how to log in from Ring class. Okay. Okay, good. I can see some bullet screen message. Okay, thank you. Okay, then we start our class. So today's class, we will learn actually from this semester. Throughout this semester, we will learn OOP language together. And this language actually is taught by English plus Chinese. Actually, we have to use English because we have some foreign students and they know very few Chinese. So we have to use English. Sorry about that. But for those students, for those Chinese students, if you are here to learn English, so maybe you will be disappointed because my English is not good. But anyways, you may be able to practice English by reading our book because our references are in English. Okay, so I think if you are here just for learning English, then I may suggest you to switch to the Chinese class because in this class, actually my English is not good. So if you only want to depend on reading the books, then that's fine. Otherwise, you may be disappointed. Okay. Thank you. And also, because this class is in English, mostly in English, but for those very difficult part, I may use some Chinese. So I want to apologize first to those foreign students. Sometimes I may use Chinese. Okay, please be understandable. Okay. Okay, then this is today's class. We will learn something about the contents and targets and grading. Also, we will learn some new stuff. Actually, the time is a little urgent for us. Okay. Then this is the content. I think as we learn later, we will learn every item later. I will not explain this in more detail. Okay. Basically, around the OOP programming, classes, objects, and other features. And this is our textbook, Thinking in CPP Language. Actually, this is a reference textbook. It is not mandatory for you to learn all by yourself on this book. Actually, there are also other suggested references. And for design patterns, we will learn. We will use this. This Bible actually is invented by or written by Gang of Four, Enrich Gamma. There's also another very good book. It is Head First Design Patterns, and this is easier for you to read and understand. So you are recommended to read this book. This is easier for understanding. But the book by Enrich Gamma, etc., is a Bible. Okay, so that's why we still suggest you to have one. And this is our textbooks. Actually, I know that most of you may have some difficulty in buying the books. So we will put online in our Tsinghua Web Learning for you to download the digital version. But there may be some copyright issues. So this is only for you to learn by yourself, okay? These are other references. The most recommended ones are the website and also CPP Primer. Okay, the CPP Primer is, I think, is a very good book for you to learn CPP language. And also, there are also more effective CPP and related versions. This is for you if you have more time to learn. And also, this effective CPP is a little easier for you to understand. If you are just a beginner, then this book may be suitable for you. There are also some other materials. I think these are for more advanced students. If you really have time, you want to learn deeper, learn more language related features, then you may read these books. These books are actually harder to understand, I think. And now we have a very brief introduction of the history of the programming language. Actually, the C programming language is it is the father of CPP language, and then C originates to the 1960s. The first OOP language is similar 67, and then there's a language B. So this language B is invented by Ken Thompson. I think maybe some of you know this person. If you know this person, you can send some bullet screen message. Ken Thompson. Do you know him? Actually, Ken Thompson is a very famous guy. He's the inventor of B language. Actually, B language is the father of C language, and also, it's also the father of CPP language, right? Because CPP also comes here. And also, Ken Thompson is the inventor of Unix system, and he is the Turing Award winner. We will also know him later when we introduce the Linux system. Okay. And then in 1979, there is a language called C with classes. So actually, this John Stroop invented this C with classes. So he used the same compiler for C and added some classes structure. Just based on that compiler, you do something else. Then you translate the classes into ordinary functions and the variables. Then it works. So he just did something incremental work, but it is a big step. After that, he invented this CPP language. He renamed the C with classes language to CPP language. So this is a brief history of the CPP language. If you have more interest, you can investigate in more detail by yourself. Okay, then this is the positioning of our class. We assume that you have learned the fundamentals of programming. if you do not have this basics, you may have some difficulty in learning this class, because our projects and also homeworks are kind of challenging. So if you are, for example, if you just learned or you have just very few programming basics, then I want to suggest you to quit this class. OK， 就是如果同学们如果这个编程基础就是零基础的话，我建议大家就可以旁听，或者是就退出这个课程了，因为我们的课程的大作业和这个训练平时的作业都比较难，所以大家注意一下这个问题。OK， then in our department, after we learn these fundamentals of OOP language, we will learn program and training, and for this class, we need to use the inheritance polymorphism learned in this class. Okay, then after that, we will learn data structures class. In this class, we will need template. This is also learned in our class. And then after that, there is also another class named software engineering. This is a third-year class, I think, for third-year students. Then in that class, they need some design patterns. We also learn this in this class. Okay, and also in this class, we will also learn something related to Git and GitHub. We have some exercises on this because the teachers of this software engineering complain that even in the third year, our students still cannot use or do not know Git and GitHub. So we will also learn this. 这个 Git 和 GitHub 就是一个远程的版本控制的一个系统啊。我们在这个课上也会学一点点，因为后续的课程需要，但是没有课程讲这个事情，所以我们在这个课程上会有一点点这个训练。Then this is the target of our class. After learning this class, I want you to master the CPP grammars first. And then I hope you are able to develop software systems using this OOP language for both engineering or scientific research purpose. And also, I hope you to, after learning this class, to have the basic software design skills using simple design patterns, because design patterns is also based on this OOP grammars. So after learning this class, I hope you to be able to finish some projects, maybe of about 1 or 2,000 lines of code, maybe. Okay, so this is our target. If you have any questions, you can send some bullet screen messages, okay? Then I will know your questions, okay? Okay, then for practicing, in previous years, we usually come to our computer lab for practicing, but now circumstances do not permit us to do that. Okay, after class, I think for every week, you may need 2 or 3 hours to finish our homeworks and also projects. Okay. For practicing, so because we cannot come to our computer lab, we have to use VirtualBox and Ubuntu. Yes, we have the remote Ubuntu server. If you have difficulty in installing your VirtualBox on your local machine, you just contact our TA. It's fine. And the VirtualBox can also be installed on Mac OS, I think. So you can have a try. We already have the documents uploaded on our Tsinghua Web Learning. You can download the documents and find the VirtualBox version that can be installed on Mac OS. After you installing this Mac OS, after installing this VirtualBox for Mac OS, then you can install this Ubuntu, okay, server. Then this is a practice environment. If you have difficulty, please contact our TA, Mr. Ji Weiqing. Okay, and his contact information is on our Tsinghua Web Learning. I think this is the most important part, the grading policy. Because we have some exercises, and these exercises are going to be reviewed by other students. So it is better for us to have some uniform compiler and uniform platform. In that way, your program will be compiled well in others' platform. Otherwise, there may be some problems. But I think most problem can be solved. If you really have some difficulty in using Ubuntu, please contact our TA. 就是我们还是希望大家有统一的这个练习的平台，因为我们的平时作业呢是希望大家互相传唤来，互相判了，互相来判，互相来那个通过这种方式呢，可以有一些这个经验的分享，比如说看看别人的作业是怎么做的，别人代码是怎么写的，别人代码风格是怎么样的，这样的话我们可以互相学习。所以这样的话，也希望大家有这样的统一的平台的话，互相之间这个代码编译起来会更容易一些。要不然的话会有这个一些问题。Our homework is a little different from the Chinese class because our class is in English, and also we have some, actually this is small class. We also have some in-class report and presentation, and also the requirements are a little different. Okay. I think VMware is fine. Yeah, as long as you can run Ubuntu, that's fine. Okay, so for the grading policy, attendance and the in-class questions, this is interaction, right? And you have to submit your answers through the ring class. Okay, we will have some questions today, and then you can submit some answers. And attendance and in-class questions takes 10% of our grading. And also we may ask you to preview something, because in our class, because we have some interactions, we do not have enough time to learn everything. So we may need to learn something after class. Then in the next class, we will have to preview how you have learned that part, and then we maybe have some small questions for you to answer, and this takes this 10%. Presentation, English or and Chinese are both fine. 就中文和英文的这个 presentation 都可以啊。So for this in-class presentation, I want you to have some about 8 minutes to present on the suggested topics. We will have a list of suggested topics, spreading from compiler, and also the Linux environment, and also debugging, and also version control, different topics. And if this topic does not cover your interested topic, you can apply to me, I think. Send me an email and state that which topic you want. Then I will have some evaluation. If it is good, then it's okay. 就是这个 in-class 的 presentation 啊，大家如果是对我们给的这个 list，觉得没有自己想做的这个present 的内容，自己也可以用自己的内容，但是要提前跟我联系，我们确定一下，就觉得这个内容是适合进行 in-class presentation 的就可以。这个今年的这个作业哈，待会儿我再讲哈，就是大作业，我们今年的大作业，只有一个作业啊，只有一个 individual 的这个 project， 就是 in previous years we have both team and individual projects, but this year we have only individual projects because team working seems a bit difficult for us right now. Okay, and then for homeworks, we have some exercise and small projects, and also co-reading. So we will have some co-reading topics, and I hope in this way you can read others' code, typically classic code, how they write classic code, then we can learn from there. OK， 就是我们会有一个代码阅读的一个练习。这个练习呢，就是希望大家能够读一读经典的代码，看看别人是怎么样写这么好的代码的。通过读代码，我们学习如何写代码。OK， then the lab exam and PA. So for this problem assignment, we will have only individual PA. There's no teamwork. Okay, and for the lab exam, it depends. If we can come back to school in time, then we may have some lab exam. Then we will have some 2 or 3 problems to be answered in our computer lab. Okay. And then I just mentioned that we have to practice some QA. And this practice the GitHub. This is the requirement for software engineering class because there is no sorry, I think there's no ACM problems. Okay, we practice more on our for the because we have learned classes and inheritance, polymorphism. Mostly we will test that part. We will not test ACM problems in our lab exam. Okay. And then this for this GitHub, I just want you to practice. So you just submit 5 times on our QA list. I think currently the QA list okay. Sorry, I did not get the point. So you mean sample questions? I think the questions we will answer some questions later. I think then you can use the ring class. I think simple question is fine. Okay. And if you really have some difficulty in using ring class, then please let me know. And that does not count. 就是说，如果使用语课堂真的有困难，这个可以跟我讲啊。就是这个 lab exam 的 sample problem， Yes, we will give some lab exam sample problems for you. Okay. Okay, then for this GitHub, there are some, I think there are some bugs to fix, and also you may also add other contents. Then you can contribute 5 times. Then you can learn how to use this Git and GitHub. Okay, and finally, you will have some final report to summarize what you have learned. That is at the end of this semester, you can submit the final report. Okay, any questions on this grading policy? Okay, if there is no questions, we'll start to learn something new today. Okay, so for command line arguments, I asked you to preview, right? So we will not have much time to learn this. But actually for this command line arguments, there are 2 key parameters in this main entrance function. One is argc, other one is argv. The argc gives the number of arguments, including the name of the executable file. Also, argv is an array of character strings obtained by the command line by the system. Okay. Then we can practice, have a demo. Okay. So this is our Ubuntu system. Then you can input the password. Password is hidden, you know. Then you can open a terminal. So there are some basic commands. For example, cd. Cd is go to the directory you want. Change directory. And then pwd gives you the current directory. So this is actually your home directory. Okay. And then we can go to some demo directory. Then here, so ls list all the items in this directory. Then we can have a quick look on the program. So we can see here. So we have some command line arguments. These are the parameters. argc and argv are used to take the parameters. And then we have this. We want to iterate all the parameters or all the command line arguments. Then we print the arguments like this. Then we return. So the program is very simple. I think easy to read. Then we can compile it. So this is our compiler. It's GPP. Just compile it. Now we can see here. If we use ls, actually ls lists all the items, but we can provide some options for this ls. Then you can list more detailed information of each file. Now you can see here. Here we generated a new file, right? This is the executable file. Then we can run it. If you want to run it, you have to use this way. In this way, system can find your program that you want to run. Otherwise, if you just type a.out, if you have difficulty, you may not be able to run it. Okay, so you run it in this way. You can see here, if you provide nothing, then there's only one argument. This is the executable file. If you give it other parameters, then we can see you get it correctly. And also you can test the double quotes, right? Then for double quotes, it is regarded as a single argument. So this is the difference. Okay. So command line arguments provide a way for us to read input from command line. And this is command line, right? Because you are typing commands here, and this is line by line. If you press enter, this is line by line, right? So this is command line, and actually on Windows, there's also some command line, you know. That is CMD, right? CMD. This is Windows command line, right? You can input some lines here, right? Like this. Okay, and this is a command line arguments. Actually, it's very easy, I think. Not very difficult to understand. It just provides a way to read something from command line, right? Then there's another program. It is sum program. If you want to read some numbers from command line and compute the sum. So there's the you can see here. Here is the sum program. You get the sum, initialize 0, and then you get every input. Note here we start from 1, right? Because the 0 item is the executable file, right? So we start from second one, and then by this function, we convert the string into numbers, and then we compute the sum. Okay, then we output the sum. In this way, we can have a very simple calculator. After compilation, you can see here, it is just generated, right? Just generated. This is the time. And we can run it. You can see here, we can get the sum of randomly input numbers. Right? Like this. Okay, and this is the command line arguments. Actually, it is not difficult to learn. Any questions? If you have any questions, I think there are two ways. One way is to use Zoom, right? You can use Zoom to ask in this by just speaking to me. Another way is to use the bullet screen message. Any questions? Okay, then if you do not have questions, I will have one question for you. Let's have .1 minute. 1.5 minutes for you to answer. So this question is, which definitions of the main entrance function are correct? There are 4 options. Please select the correct ones. This is multiple choice question. Please answer the questions. Please answer the questions from Rain class. Okay? From Rain class. Answer the questions from Rain class. Please answer the question from Rain class. Okay? Please do not answer questions from Zoom. There's no way to answer from Zoom. Okay? You can see here. So this is the answers. A, B, C are correct. D is not. Because D, we cannot take an integer argument here. And if there are no arguments in this main entrance function, then we just do not take any command line arguments. That's fine. That means our program will not run in a way that it takes some arguments following it. It's fine, right? Okay. Now we will learn something related to compilation and the multiple file projects. So for compilation, we need a translator. It translates from source code into machine instructions, binary code. Okay. Source code are text files, and the machine code are binary code. 就是源代码一般都是这种文本的文本格式的，对吧？我们写 C 加程序都是文本的，但我们要把它翻译成一个二进制码、机器代码，这样才能执行。So there are 2 types of translators. First one is interpreter, another one is compiler. Actually, most IDEs have some integrated translators. For example, code blocks have G++. And Visual Studio also have some Windows compiler. So in previous years, we used code block. We just used the compiler in code block, but I think is not so good, because code block are often installed on Windows. But actually, if we want to, for example, if we want to finish some projects, especially for scientific research projects, most projects are implemented on Linux. So if we directly use Linux, then it's easier for us to learn the compiler, the environment, and also for our the PA, it's easier for you to install the libraries. 就是这个前几年我们都是用 code block， 但是呢，就是 code block 是在 Windows 上装的，但其实它有点怎么讲呢？就是稍微有点那个不伦不类哈。就是说，为了学习 C++， 为了用 compiler 就用了这个，但是实际上，以后大家做科研或做工程的话，可能用的很少。所以我们今年直接我们就用 Linux，更偏重于比如说一些 科研环境啊，都是在用 Linux 在做这个研究的项目都是在 Linux 上来完成的，所以我们可能这样的话，以后我们都会用到，会对大家有更多的帮助。Okay. Visual. You mean Visual Studio, and it's also good. But Visual Studio actually is Windows related, and most applications are from Windows, and it's also another way, I think. We will also think about it, but some professors and researchers suggest us to use Linux. I think if you have some interest, you can use Visual Studio by yourself. But for our class, we just use Linux. I think in many foreign countries, their classes they also use Linux. So Linux is also a good option, I think. Okay, for CMake, we will mention about it later. Okay. So for this translator, there are some interpreter. So the interpreter is executed during translation. So when it translates one line, then executes one line. So the interpreter runs together with the program. So in this way, it consumes more memory during runtime. And also the efficiency is bad because we have to first translate one line and then execute one line, and there's no optimization of the code. But for compiler, it's a different way. The compiler first translates all the source code into machine code and then run it. So there can be many code optimization techniques to optimize the code for better efficiency. And only the machine code runs in memory, so it takes less memory. And also the efficiency, because we have done some code optimization, efficiency is better. C and CPP language are typical compiler supported languages. And the Basic and Perl and also JavaScript, etc., are interpreter related languages. So for this compiler, we will have compiler class in the third year. In that class, we will learn more about compiling optimization techniques. Okay. So this is our compiler. It's Ubuntu, our compiler on Ubuntu. There are also many other compilers. Some students just mentioned that there are some Visual Studio compiler, right? There are also Intel, Borland, Apple, also MinGW, right? This is on Windows. There are many different compilers, but we use this GPP. I think this is a typical compiler, right? For many different products, we can use GPP compiler to do that, compile it. And there are many options for GPP program. For example, we can have a look of the compiler. So we can see here, this is the version of the compiler. So by typing GPP help, you can get a long list. Okay, let's have a 5 minutes break. We will learn how to write code later, okay? Okay, let's start our class again. So we just learned the compiler, and you can see that compiler version. I just this is compiler version. So please be noted that this is the key, because even the same source code may not work for different compilers or different compiler versions. So if you provide someone with some source code, you need to tell him what compiler you use, what compiler version you use. Okay, this is very important. Otherwise, even the same source code may not be compiled correctly. There may be some compiling errors because different versions of compilers have different grammars. This is very important. Okay, that is why I want all of you to use the same platform, use the same Ubuntu version, same GPP compiler. Okay, so this is a key for that. Okay. Okay, now we will learn this project with multiple files. So actually, in last semester, our students learned these fundamentals of programming. Actually, I heard that most of you are just writing a program of a single file, right? But for large projects, maybe it consists of more than 2,000 or 5,000 lines of code. You cannot just use one file. So it is typical that the large projects are partitioned into different modules, and then each team may work on one module. Then this enables modular programming. So multiple file projects enables modular programming. Here is an example. We can see here, if you want to write an adder and multiplier program, then there are different parts. Maybe this is a very simple example. Maybe in real applications, there are very large modules for different teams. Okay, then we assume that these different parts are written by different people. Then we will have this. This is the main program, and in the main program, we call these different functions. And then these are the functions. This function is defined in this source file, and this function is defined in this source file, and this source file. Then we compile it. Does it work or not? Let's have a try. So we can see here, this is the main program. And this is the sum program. Please note that I strongly suggest you not to use Chinese characters in your program, because it sometimes causes weird problems. And also on Linux systems, it is often not supported. Chinese characters is often not supported. Okay, please use Chinese English characters. Then here is a product. Okay, use English characters. Okay, then we try to compile it. You may provide all of them together to the compiler. Then it will compile it. But now you can see here. So in this main program, sum is not declared, and also product is not declared. So this is the error. Does not work. If you use multiple files, you just define it in different files, then the functions cannot be called directly. how to solve this problem? This is declaration. When we use the function that is defined by others, we have to declare it. Okay, and this is a way to solve this problem. So a function or variable can be defined only once, but can be declared many times. The keyword for the declaration is extern. This is the keyword. For variable declaration, we use extern like this. Now for function declaration, we can use extern like this. But here, for function declaration, this extern can be omitted. That means you just omit this part. It's fine. Okay. Then this declaration are often stored or are typically stored in the header files. So for multiple file projects, headers are very important. We need some header files. So header file is a text file where functions and variables are declared. And also we will learn classes and templates later, and they are also defined in header file. Classes are similar to struct. Okay. And the file name often has some suffix like this, .h, .hpp, or .hxx. And we should not define variables or functions in the header file. We just declare variables and functions in the header file. Okay? Because definition of variables and functions in the header file often cause multiple definitions error. Okay. So in the header file, we declare the functions and variables. And then in the source file, we include the header file. Then it will work. Okay. How to include the header file in the source file? We need a preprocessor directive, .include. This includes the headers into the source file for compilation. There are two ways. One way is to use angle brackets like this. And this header in the angle brackets are typically for system headers, because by giving this angle brackets, it means the search path for this header is environmental variable path. Actually, for Windows, for Linux, for Unix, they all have environment variable path. In this path, system will search for the specific file. There's another way. If in this path there's no such a file, then it will search here. If you compile your program with this option, we just mentioned that we just typed, right? The G++ help, we get all the options. So if you provide this option, then the compiler will try to find this file in this directory. Okay. And if we include some header file in this way, it will first search in the current directory. Current directory means the compilation is launched here. You just typed compilation here. This directory, you type this compilation command in the current directory. So if the header is not found, then compiler will search again in the same path as angle brackets. Okay, so typically for system headers like this, we use angle brackets. For user-defined header files, we use the double quotes. Okay, so this is typical rules. And there's a suggestion we should include related header files in all the source files where the declared functions are defined or used. It's like this. Sorry. We will give a demo later, okay? No, this -I means it directs the compiler to find there, because we are running the compiler. This is the program. The program will find the header in this directory. This will not modify the path environment variable, okay? So this option tells the compiler to find the file in this directory. It will not modify the path environment variable, okay? There's no space. It's -y, then directory. Okay, maybe we will have some demo now. So you can see here is an example. Here's the source file, and this is header file. We just mentioned that in the header file, you are suggested to just give some declarations. So this is declaration of function. You are not suggested to add some function definitions. This is not correct. We should not give the definition of the function in the header file. But if we give the definition here, what will happen? Let's check about the results. So in the main function, we include the header file. And in the product source file, we also include this header. Then in the product.cpp, we also define the product function. So basically in this main.cpp and the product.cpp, we include the same header file. And in the header file, we define the sum function. Then let's check what will happen. Now we can see here, this is multiple definition error, right? Multiple definition error, because in this main.cpp, we included this header, then this means in main, we defined this sum function. And then in product, because the header is also included, so the sum function is also defined in product. So in this way, we get a multiple definition error. Okay. That means multiple definition of this, you get the error. That's why we suggested you not to define functions in the header file. We just declare functions in the header file. Okay. And also, there's an inclusion guard for headers. So this is a guard macro. It's typically used for headers. So macros are processed by the preprocessor. That means before the compiling process. It's a text process. So this defines the macro. XX. So this is a name. XX is a name. Then if NDEF checks whether this name is defined. If NDEF means if this name is not defined, then go forward. Otherwise, if it is defined, then skip the following part before the NIF. So this is the header file. In the header file at the beginning, we check whether it's defined or not. If it is not defined, then we define it. Then this is the NIF. And this part, this if and NIF. This part is enclosed in this if and NIF guard. So in this way, it avoids the header to be included twice. Avoid the header to be included twice in one source file. Okay. If we do not have this guard band, that include guard, this name is actually okay. Let me check if there are some. Let's have this example here. Here, this is functions.h. You can see here, we have a guard band and the include guard like this. So this is actually you have uppercase. That's better. Like this. Okay. Then maybe we just forget it because of time. You can change all this into uppercase. That's better. Typically, we use uppercase. Then this is a macro we defined. We check if this is defined or not. If this is not defined, then we define it. Then this is a header. So we have a class here to test whether this header file is included twice. Class is also class is similar to a struct. If it is included twice, there will be some error. But this one, the function declaration can be included many times. It does not generate error. So that's why we use a class definition here to test. Okay, then this is a typical way of writing this inclusion guard. Then we can see here in the main function, in the main file, we included header file. So the preprocessor will first check when we compile the main.cpp, the preprocessor will first check if this is defined or not. For the first time, it is not defined, right? So it will go forward into this part. If it goes into this part, it will first define this. So it's already defined now, right? So when the header is included the second time, this function h macro is already defined. So it will not go into the same part again. Am I clear? Because if you include this header a second time, for example, here, here we have another, sorry, open too many. So here's another header file. We also have this including guard. For example, if we do not have this guard, if we comment out, and then comment out this, then we can see here, because this functions 2.h includes functions.h. So these two lines will include functions.h twice, right? Because in this function 2.h already includes this. And then we include once again, right? This is once, it's another time. So this function.h will be included twice. Then let's check what will happen. Actually, you can also compare it in this way. This is actually it's a regular expression. This means it will match all the characters. All these source files will be compiled in this way. Okay. So we can see here, there's a redefinition of this class. Because in main, we just mentioned that in main, we first included this source file. And in this source file, we already defined this class A. And then in functions 2.h, we include functions.h another time. And we do not have the guard band, the include guard, right? Then there will be this error. Sorry. Sometimes there are some swap file. It's already opened, okay? Then if you want to remove this problem, you just open the guard. Okay, it's like this. Then in this way, in the main, when we compile the main, because in this function, we already defined this, right? Because when we first process this header file, we already defined this macro. Then when we, for the second time, we include this function.h. If we want to include this file again, then we enter this again, right? It will check whether it's defined or not. Okay, now we can see, okay, it's defined. So we will not go into this part. So this will not be defined. Am I clear? So this is the way to solve this problem. So now you can compile it correctly. Okay. I will provide the examples in our Tsinghua Web Learning. You can practice it. Try to comment it and uncomment it to find out how it works. Okay. If you still have some questions, you can contact me. We can have some discussion on this. Okay. So this is the inclusion guard. It basically avoids the header to be included twice. Okay. So this is the way. If we have another header, include this header, then the source file includes this header and this header. So in this way, header 1 is included twice. If we do not have this guard, including guard, it will be included twice. And there will be some compiling error if we, in the header file, we have a class definition. Okay. If we only have function declaration, that's fine. Okay. And this is the way how we use functions, the header files. We just suggested that in the source that we use the declared functions, we should include this header. Right? Here, we need to have some including guard. Right? In this function.h, we need to have some including guard. And then here, this is actually not necessary here because this is the file that we define the function. But if we really include this, it may be easier for us to read because in some way we know that functions.h is related to this file. So that means in this function we declare this function, right? In this header file we declare this function. So they are related to each other. It makes the reader easier to understand the program, okay? And this is a file where we define this function, and also it is declared in this header. This is the way how we use the header file and including guard, okay? Okay, and then now we will learn something about relating make. So we just mentioned that when we compile the code, we just use G++ with all the source files. This is called direct compilation. Compile the source files all at once. And there's some disadvantage of this direct compilation. When one source file is modified, all the files need to be recompiled. If we modify one, then we compile all of them. So the solution is separate compilation. So we need to save some compilation time. This way can save some compilation time of unchanged source files. We only need to compile the changed or modified source files. Okay, the linking time cannot be saved because we have to link. So this is separate compilation of the compiler. The different source files are compiled into different object files. They are separately compiled. We will learn library later. Actually, after compilation of these source files, we can link them together into an executable file. So there are some libraries. We can link libraries and also object file together to generate one executable file. So we will learn library later. Okay. So this is separate compilation. First compile into object file and then link all the different object files into executable file. Sorry. So there is a tool called Make to manage the compilation process. Because if we use separate compilation, it is actually a bit difficult to compile because we need to compile one by one, type the programs, compiling commands one by one. That is time consuming. Right? So we need a tool. But this Make tool is used to automatically manage the compilation process. So for Make, there is a special file named Makefile, and it is used by the Make tool to manage the compilation. So for Makefile, a very critical rule is, or a very critical idea is the dependency rule. It is defined by, the dependency rule is defined by comparing the modification dates. So it will compare, for example, the source file and header files with the objective file. For example, if we are compiling the source file into object file, if it is already compiled, then this A.O will have some latest time, right? Earlier time than A.CPP. But if we modify A.CPP, the time of this A.CPP will be earlier. Sorry, maybe more newer, right? Newer is better. Newer A.CPP is newer than A.O. And in this way, we know, okay, this is newer than this, so we need to compile. Okay, so this is dependency rule. It will check the modification dates. So when the dependency rule is satisfied, there will be some corresponding commands executed. It's like this. This is very simple Makefile. So we can see here, there's a dependency rule. Text.exe, this executable file, depends on this source file and header file. If any of them is modified, then this dependency rule is satisfied. After this rule is satisfied, the following command will be called automatically. Okay, so this is the idea. So this is a tab, not space. Be careful about that. So this is the dependency between the different files and the executable file. Actually, this dependency tree, but some of you may not have learned tree because this will be learned in data structure. Actually, this generates a dependency tree. When the node when this node is modified, then this will be triggered, right? The dependency rule will be triggered, and the corresponding command will be called. Okay. So this is a simple Makefile, and this is an example of separate compilation. You can see here. So this executable depends on the object files and the header files, and then the object file depends on source file and header files. If, for example, if we modify main.cpp, then main.cpp will be newer than main.o, then this dependency rule will be triggered, right? Then this command will be called. So main will be compiled. This main.cpp will be compiled again into main.o. When this main.o is generated, the main.o is newer than what? Than test.exe, right? So this dependency rule will be triggered again. So this command will be called to regenerate the executable, right? So in total, if we only modify main.cpp, only this command and this command will be called. Okay. Other commands, other files will not be compiled once again. So in this way, we save the compilation time. And this option tells the compiler to just compile, not link. This -c is compile. This -o tells compiler to rename the output file. Rename it as main.o. Okay. Then we will have one example. You can see here we have one Makefile, right? So we can see here this is a tab, this is tab, and then we have the dependency rules like this. We have some other target. We can use this target. So by typing make, I think -o is necessary. Right? Otherwise, okay, that's a very good question. Maybe -o is not necessary because if you just compile it, it may automatically generate main.o. But if you want to rename it into other names, then that's necessary. Okay, So we first make clean. So this is a target. We can make clean. If we make clean, the command under clean will be will be called. So we will delete all the compiled files, and then we make again. You can see here, all the files are compiled, but if we just touch one file, this touch command will modify the modification date. It will be newer. In this way, it will be newer than other files. So let's type make again, right? So you can see here, if we modify main, only main source file will be recompiled and also linked. Okay. So this is a make file and make. I think it's not very difficult, but actually there are many different ways of writing very good make file. So if you're really interested, you can learn it by yourself. Okay. So actually in Makefile, there's default target all, but we did not use it. And there are also other target. For example, in our Makefile, we have a clean. If we make clean, then it will remove all the files, all the object and the executable files. So Makefile could be simpler if you want. Actually, there are some tools, CMake. I think someone mentioned about that. CMake is a tool to make Makefile. Right? Currently, we write Makefile by our hand, but we can automatically generate Makefile by CMake. So CMake is another tool. If you have interest, you can learn about it. And if someone has interest in for in-class presentation on this, you can talk about CMake. Okay, we will not learn it in class. Okay, then there are some Linux basics. I think we do not have much time to learn about it today, but I will leave this for you to learn. Then in our next class, we will ask you some questions on Linux basic commands. Okay. We will learn something about this, the history. So I just mentioned Ken Thompson, right? Ken Thompson invented B, which is the father of C and CPP language. He also invented Unix system, the most widely used operating system, have the most influence in our world on operating system. Okay, CMake is not necessary. If it is for you if you want to learn or use it. And Makefile is not, we do not need to write different Makefiles. I will provide you some typical Makefile, you just modify it, it's fine. You do not need to take much efforts in Makefile, okay? So after Unix, actually there are some Mac OS and Windows and Linux. Linus is another great guy, I think, and he invented this open source Unix-like operating system. And also he's author or father of Git and GitHub, okay? And there are some simple commands for Linux. I would like to leave this for you to try. I think I just mentioned something, or I just demoed how to use some commands, right? Someone asked how to write code in Linux. Actually, you need to learn VI or Emacs by yourself if you want. If you do not want to learn such complicated editors, you can use gedit. I think in gedit, it's similar to some text editor. It's easier to use. But I suggest you to use VI. So because for Linux users, VI is very important. Okay. Okay, then this is how we list files and directories, and this is how to change the VS Code. Anyways, in our class for this semester, we use Linux, okay? Because Linux, I think, is also another very important platform. If you can use it, it's better. But anyways, we won't have exams on Linux commands, okay? This is for you to either to use Linux, but we will not test the Linux commands for you. Okay, then okay, then I'll talk about something about this, the access mode. Right? For a file, there are different access modes. For example, actually on Linux servers, there are different users. So if you are one user, and there may be other users. So do you want your file to be accessed by other users? So this gives you the permission. These are the permission. So this first one means directory. This means this is current directory, right? So for example, so these are directories. If you have a D here, it is directory. If you do not have a D here, it's minus, then it's not directory. The first 3 bits gives your owner access right. So you can read, you can write, you can execute. This, you are the owner, right? You are the owner of this file, so, or directory, so you can read and write and execute. These 3 bits are for other users of the same group. We can have some groups on the server. We can organize different users into groups. Then groups, users of the same group can. This means users of the same group can read and execute the command, this file and this directory. Sorry, and this is for other users, not in the same group. Then this is the default access right. Okay. Because it's already I think time is not much, not much time left. I just talk about that for this. Talk so much about that. Okay, you can have a try on this change mode and others. Okay, so then for today, we will learn this command line arguments and project multiple files. Also, I want you to practice Linux commands. Okay, we will also upload all the source, all the sample code onto our Tsinghua Web Learning. Okay, thank you. Have a nice day. Goodbye.